Hey students, and welcome to section 3.3, continue talking about displaying numerical data with histograms. All right, let's get right to it because this is actually going to be a pretty dense lesson right here. Histograms, what type of data can histograms display? We usually use them for large sets of numeric data. And histograms are good for displaying both discrete as well as continuous data. For discrete data, what you're going to notice is you're going to notice that the numbers act as categories. Oops, that's good. And those labels are centered in the middle of the bars, just like they would be on a bar graph. So for instance, we could have, number of pets someone has. That's discrete. You can't have 1.5 pets. So we would have 1, 2, 3 as options, let's say. And the bars would be centered in the middle. But there would be no gaps. So that's why I took that back really quick. Okay? Rough, but you get the idea. Continuous is the graph is sitting on a number line. Therefore, we are considering all values, even into decimal values, not just integer values. So it's sitting on a number line. We have class boundaries that need to be well defined. By intervals. That way we know where every single number falls. No number is going to fall, quote unquote, on the line. So for a continuous histogram, you're going to see a number line like maybe 1, 2, 3, 4, 5. And we would say, okay, these values here are going to contain all values from 1 to less than 2. And then 2 to less than 4. And 4 to less than 6. So those lines fall on the class boundary, and the boundary is well defined so that we know which direction each value falls. So we'll get into that in a little bit. All right, how do I know how many classes to use? We already discussed this with cumulative relative frequency plots, and it's a square root of the number of observations. How do you know how many numbers to put into each class? We actually already discussed this also, and this is the range divided by number of classes or intervals, and that's the amount of values per interval. Okay, what if class intervals are unequal on a frequency table? So what if you realize that some intervals are wider or smaller than others? Well, then in order to appropriately identify them, we would have to use density on the y-axis. Okay, and that's rather than frequency or relative frequency. And here's your density formula. Density is equal to the relative frequency of the interval divided by interval width. That way we can compare densities, but we cannot really compare relative frequencies because they're not going to be on the same level. They're different widths, so that's not going to be fair. But the density we can look at and compare, as you will see in your examples tonight. The y-axis is always going to be labeled as frequency, relative frequency, or in those specific cases, density. Those are your top 3 labels for the y-axis. All right, ways to analyze and describe histograms. It's really important that when we draw histograms, the reason why we're drawing them is so that we can make sense of our data. And most of the times it's a very large data set that is being used by a histogram. So we want to make sure that we have accurate information that lets us describe a bunch of data. So we have 3 options. We can have a graph that is skewed to the right, a symmetric graph, or a graph that's skewed left. One thing you need to remember about the skew is always where the tail trails. So over here we have a tail to the right, which means skewed right, and over here we have a tail to the left, which is skewed left. My neighbors are gardening, and I hope you guys can't hear that. OMG. Another thing is, with a completely symmetric distribution, regardless if it's bell-shaped or not, with a symmetric distribution, usually your mean, median, your mode will kind of change depending on if it's symmetric or not, bell-shaped or not. But your mean, median, and mode are all the same value. With a right skewed distribution, your median and mode will pretty much stay the same. But we know that your mean will be influenced by those higher values out here in the tails, and your mean will be pulled towards those values. So in a right skewed distribution, your mean is always greater than your median. Here they're all equal in a symmetric distribution. And over here, in a left skewed distribution, your median and your mode will probably stay relatively the same, but your mean will drop. So you would have your median and your mode still be at those maxes, but your mean will be influenced by these lower bound values. So in a skewed left distribution, the mean will always be less than your median. And here your mean will be mostly equal to your median, if not very, very close. So those are some descriptors in regards to shape. So these are all descriptors for shape. Okay, so now we're talking about some descriptors for the number of peaks on a graph. Unimodal graphs have just one peak, and here's one example of that. So we just have one peak. Bimodal graphs have 2 peaks. They don't have to look like that. That's just one example. And multimodal graphs have multiple modes or peaks. All right, now that we've got some basics about histograms, we're ready to go ahead and do our first example. All right, so let's read this first example together. Medicare's new medical plans offer a wide variety of choices for seniors when picking a drug plan. The monthly cost for a standalone drug plan varies from plan to plan and from state to state. The accompanying table gives the premium for the plan with the lowest cost for each state. Construct a histogram and comment on its shape. Okay, we're definitely going to need a table to create a histogram. One thing I do want to tell you, if you don't remember, that is going to be very helpful since we have 51 data points here. There's 50 states, plus we included the District of Columbia, so that's 51. It can be very taxing and annoying to put all of these in order or into a table. So what I suggest and what I always do is I right away put these into my calculator. So your calculator can help you by hitting, not second, stat edit, and enter all of these values into list 1. When you've done that, exit out, hit stat again, and then that function sort A for list 1, and it will sort all your values in ascending order. This is so helpful because it helps you see the minimum, it helps you see the maximum really quick, and it also helps you put the numbers into a frequency table very quickly. Okay, so that's what I did. All right, throughout these examples, you may have to pause to catch up with me, and that's completely fine. And there's going to be times where I tell you, let's pause, you do this on your own, and then check with what I've done too. Okay, so to determine the proportion of the states, or to construct the histogram, I'm going to take the square root of 51, and I get 7.14, which lets me know I'm going to have 7 intervals. My range here is from 20.05 to 1.87. This is 18.98 divided by 7, and that gives me 2.711. So I'm going to have 3 values per interval. So let's go ahead and set this up. I've got my intervals and my frequency and my relative frequency are going to be next. I'll explain everything. The lines do not snap the same. Okay, so let's do this. I'm going to start off at 0, and I'm going to go to less than 3. So 0 plus 3, but less than 3. Because remember, this is a continuous graph on a number line. I need to let everyone know where the value 3 falls. And in this case, it's going to fall in this next bracket, 3 to less than 6. Those less than signs are absolutely required of you. You have to put them so that your reader knows where marginal values fall. Okay, so 6 to less than 9, 9 to less than 12, 12 to less than 15, and 15 to less than 18, 18 to less than 21, and we are done. Okay, so those are our intervals. They absolutely do need to notify us of where marginal values fall. That way values never fall, like we said, on the line, okay? All right, I'm gonna pause this video, and I want you guys to go ahead and collect those frequencies as well as your relative frequencies. If I were you, I would definitely use the trick on my calculator. All right, so you can go ahead and look at my table and see what my frequencies and relative frequencies look like. Depending on how you rounded, this may be a little different for you. I do not care, remember, as long as we are within 1% above or below 100%. So 1.01, perfectly acceptable. All right, now we're gonna move on to our histogram. We're gonna come down here. We're gonna make sure that we label our X and our Y axis accordingly. So I'm gonna go ahead and do that. I'm going to pause this video. You do that too, and then we'll come back to make the histogram. Okie dokie, so as you can see, I labeled my Y-axis with relative frequency. I labeled my graph with monthly health plans, and I labeled my X-axis with cost per month. I want you to note that this is fortunate that I was able to start at 0 and then correspond directly to my intervals with these values 3, 6, 9, 12, 15, all the way to 21. But you do need to be aware that you do not do anything misleading with this value 0. this always needs to be a number line. So you have to decide if you need a break, if you don't need a break, if you need to start and leave a little gap in the front, whatever it needs to be. But remember, this x-axis is always a number line. So we have to be careful about how we label that. All right, so now I'm gonna go ahead and start building my histogram. So from 0 to less than 3, I have 0.14 as my height. So right here, this tells me from 0 to less than 3, those values are going to be within here. And I know 3 does not fall on this bar, it's going to fall on my next bar. So that's because of the table. The table is so important. So I've got 0.06, 0.29, 0.22, 0.16, 0.08, and then 0.06 again. All right, it asks to comment on the shape of this graph. This graph seems to be slightly skewed to the right, possibly. Not strongly, but it does seem to be slightly skewed right, which would indicate most healthcare plans are affordable and between, you know, $6 to $9 a month, where a few are more pricey. Okay, so most values fall within this range here, but a few trail off, okay? All right, we can also know that there's kind of a drop between the values of 3 and less than $6. Alrighty, and question B asks us, determine the proportion of states that have a minimum monthly plan of less than $13 a month. So for part B, for less than $13 a month, I'm looking at my table and I can go from here back and add all of those values up, and I would get that that would be 71%. So I know it's not 71%, but I know it's less than 71%. So I'm actually going to say, okay, less than 71% of states have a minimum monthly plan of less than $13 a month. Okay, so when in doubt, when things can't be precise, remember that we can always kind of estimate and use what we know to describe. All right, so you guys do have some practice problems, and I just want to go over them really quick with you. Question 1 is about shape. Question 2, I just want to point out that if you notice for question 2, these 3 intervals are the same width, and these intervals are the same width. So for this graph, for number 2, you are going to be using density on the y-axis. So on the x-axis, you can keep this interval width. These are going to be larger than these. That's fine, as long as your y-axis is density. Okay, so that's what we're looking for question 2. In order to help with this question, I would set up a table, maybe on a separate piece of paper down here, that is made up of relative frequency and then density for each of those intervals above, because that will help you answer that question. Also, one thing you need to remember when answering these two questions, question B and C, is that you will not be able to look at the graph to get those answers. You're going to have to use the table. Okay, and divide by the total. Because your graph will give you an idea of the display overall, but it won't be able to give you a very specific idea as far as categories go because we're looking at density and the intervals are different, okay? So that is it for today. Make sure that you get those two examples done and be ready to go over them in class on Friday. See you.